Hello, and welcome to Space Science Before Sleep. If a galaxy could breathe, where would we hear it? In the hush between the stars, or in the slow turning of everything we call home? Maybe it has been a long day, and your mind is still carrying small, unfinished thoughts like loose papers that have not yet settled. You have got nothing to do but rest. Let your breathing slow a little, and allow your shoulders to soften, as if they are gently untying. You can let your body feel a little lighter, as though the weight of the day is being placed on a quiet shelf for the night. Tonight we are drifting through the Milky Way, not as a map of sharp lines, but as a calm living swirl of motion, memory, and faint light. If this helps you unwind, consider liking and subscribing. One calm orbit at a time. Now, let us begin. There is a kind of timekeeping that does not need clocks, calendars, or alarms. It is the kind of time that is measured by repetition. So slow, it feels like stillness, by a circle, completed so gradually that no single night could ever notice its progress. Our planet turns once each day, and we can feel that, turning in sunrises and shadows in the way evening arrives, like a curtain drawn across the sky. The Earth goes around the sun each year, and we notice the seasons, the angle of light, the shifting length of afternoon. But the sun itself is also traveling, carrying the whole solar system with it, and that larger journey has its own gentle rhythm. Astronomers sometimes speak of a galactic year, the time it takes the sun to complete one full orbit around the center of the Milky Way. The number is not something you need to hold tightly in your mind, because it is almost too large to grasp in one piece. It is hundreds of millions of years, a span that holds continents reshaping, oceans opening and closing, and countless generations of living things coming and going like soft waves on a shore. If you imagine that immense orbit as a single year, then human history becomes a brief evening breeze and a lifetime becomes a single quiet breath. And yet, even if it is hard to picture, it can be soothing to remember that the galaxy provides its own steady pace. A slow, dependable motion that does not rush and does not hesitate. Right now, without needing to do anything, you are moving through space in several ways at once. The Earth spins. The Earth circles the Sunday. And the Sun, along with every planet, moon, and comet that belongs to it, glides around the Milky Way. You can let that thought be gentle rather than dizzying, because this motion is smooth, and it has been smooth for a very long time. In this larger orbit, our solar system is not traveling alone. It is part of the galactic disk, a broad, flattened region where most of the Milky Way's stars reside, including the familiar ones we see as a band across the night sky. The disk is not like a rigid plate. It is more like a wide, quiet drift of stars, gas, and dust, all moving in shared rotation, each piece following the gravity of the whole. The galaxy holds us with a calm steadiness, not like a grasping hand, but like a deep current that guides a leaf along a river without struggle. If you have ever watched a slow carousel, you might remember how the horses rise and fall, and how the world beyond the ride seems to move in the opposite direction. A galactic year is like that, except unimaginably larger, and without the jolts or bright noise. It is a turning that takes its time. The Sun's orbit is not a perfect circle in the way a simple diagram might suggest. It is shaped by the distribution of mass in the galaxy, and by the gentle irregularities of a system that is alive with motion. But the overall idea remains simple. We are part of a vast rotation, and our place within it is one small thread in an enormous woven pattern. The center of the Milky Way lies far away from us in the direction of the constellation Sagittarius. We are not near the middle. We live out in the disk in a region where stars are more spread out, and where the night sky can open into wide, dark spaces between points of light. From here, the galactic orbit feels like a soft promise. The center is a distant anchor, and we, along with everything in our local neighborhood of stars, move around it in long, unhurried arcs. It can be restful to imagine that the galaxy does not demand attention. It turns whether or not we watch it. It carries us whether or not we understand every detail. And the idea of a galactic year can become a calming clock for the mind, because it reminds us that time can be immense and gentle, not only urgent and sharp. While your thoughts slow down, you might picture the Milky Way as a quiet wheel, turning so slowly that the motion feels like peace. To make that image clearer, it helps to think about what is actually moving. Stars in the disk are not fixed pins. Each one follows its own orbit, guided by gravity. Some travel a little faster, some a little slower, depending on their distance from the galactic center and the distribution of mass. Gas clouds also orbit, and within those clouds, new stars can form, then drift onward with the rotation. In that sense, a galaxy is not a still picture. It is an ongoing circulation, like a very slow weather system, except made of starlight and thin mist. If you could float far above the Milky Way and look down on it, you would see a broad disk with a bright central region, and you might notice curved patterns sweeping outward. Those patterns are the spiral arms, which we will explore in a little while. For now, it is enough to hold the feeling of rotation. The spiral shape is part of that rotation, a pattern that emerges from motion over time. A galactic year is the long cycle in which such patterns persist and evolve, like music that repeats so slowly that each note has time to fade into the next. The Milky Way is also old. It has been turning for billions of years, completing many galactic years, each one carrying the galaxy through slow changes. Stars are born and die. Orbits shift slightly. Small galaxies drift close and get absorbed. Streams of stars stretch into faint arcs. But the overall turning remains a steady rotation that has the patience of deep time. You do not need to memorize any numbers to feel this. You can simply allow the idea to rest in your thoughts like a warm stone. The sun is moving around the galaxy. The galaxy is turning. And you are here safe on a small world, listening from inside the motion rather than outside it. If the Milky Way had a heartbeat, perhaps it would not be a thump or a rush, but a slow pulse measured in orbits, a rhythm so calm it can lull a tired mind towards sleep. In the sky, we often see the Milky Way as a pale band, a soft river of light. That glow comes from countless distant stars too faint to separate with our eyes. When the night is dark enough and the air is clear, the band can look almost like a cloud, as if the sky has a faint mist. That appearance is fitting, because the galaxy is in a way a kind of luminous mist, shaped by gravity and time, rotating with quiet certainty. As you rest, you might imagine our solar system as a small boat on that slow current. It rides along with the disk, keeping pace with the galactic flow. Planets keep their own orbits close to the sun, like small circles drawn on a moving page, while the whole page glides through the larger story. There is comfort in that layering of motion. The small rhythms of days and years are held inside the larger rhythm of the galactic year, and all of them are steady. In the coming parts of this journey, we will let that galactic rhythm guide us into the spiral arms, into the unseen scaffolding of dark matter, into the quiet history of collisions that shaped our home, and finally, toward the heart of the Milky Way itself. But for now, in this first gentle beginning, you can simply rest with the sense of the turn. The galaxy is a calm clock in the dark, and its hands move so slowly that they feel like stillness. If your mind wanders, it can wander softly. If a thought arises, you can let it drift by the way a small cloud drifts across the moon. There is nothing to solve tonight. There is only the steady, quiet fact that we are part of a long orbit, and that the Milky Way carries us along one calm orbit at a time. As you continue to rest, you can let the idea of the Milky Way's slow turning settle into the background of your thoughts, like a low, steady note that does not ask anything of you. A galactic year is so long that it can feel abstract, but it also offers something soothing, because it reminds us that the universe has rhythms that are patient, rhythms that continue whether or not we pay attention. When you are tired, it can be comforting to imagine time not as a list of tasks, but as a wide, quiet river that carries everything gently along. Our sun is one star among many, and it travels with a loose family of nearby stars, each one following its own path around the galactic center. This is not a tight marching formation. It is more like a slow drift of lanterns, floating on a dark sea, each lantern keeping its distance, each moving along with the current. Over the span of a galactic year, the Sun will pass through different regions of the Milky Way, sometimes closer to the brighter bands of star-forming activity, sometimes in quieter stretches of the disk. But the changes are gradual, and the movement is smooth enough that the solar system remains stable, held in place by the Sun's gravity, even as the whole system glides through the galaxy. If you were to imagine our location in the Milky Way, you could picture us not at the center where things are crowded and bright, but out in the disk, where the stars are spread more gently across space. From here, the galaxy's center is a distant glow, hidden behind layers of dust and gas, when seen in visible light, but still present as a gravitational anchor. And as we travel around that anchor, we remain inside the Milky Way's broad, rotating disk, a structure shaped like a thin, luminous plate compared to its full size. It is interesting and calming in its own way to remember that our night sky is a view from inside the system. We do not look at the Milky Way from afar like a photograph. We look along its plane and see the accumulated light of countless stars. That is why the Milky Way appears as a band thicker and brighter in some directions than others. It is the glow of a crowded line of sight where our gaze passes through long stretches of the galactic disk. When the sky is dark, that band can feel like a quiet presence, a reminder that we are inside something vast and gently rotating. The rotation itself is not like a solid wheel turning. A galaxy is not one rigid object. It is a collection of stars, gas, dust, and other material, each piece moving according to gravity. And because different parts of the disk are at different distances from the center, they move with different speeds. Closer to the center, things generally orbit more quickly. Farther out, things can move differently. This is part of what makes the Milky Way interesting, and it is also part of what makes its spiral pattern possible. For tonight, you do not need to carry the technical details in a tight grip. You can hold them loosely as gentle ideas. A galaxy rotates. The orbits of its stars are guided by gravity. Over time, patterns can emerge, not because the galaxy is painted with fixed lines, but because motion organizes itself into recurring shapes. When you see a spiral galaxy in an image, those arms look like bright pinwheels. But they are better understood as flowing regions, like lanes of slightly denser traffic on a highway. Stars and gas move through them, entering and leaving, while the pattern can persist for long stretches of time. Before we fully drift into the spiral arms, it can help to imagine what a spiral is. A spiral is a curve that winds outward from a center, a shape that can appear in many natural systems. You can see it in seashells, in storms, in the arrangement of seeds in a sunflower. In galaxies, the spiral arms are shaped by gravity and rotation, and they become visible partly because of what happens inside them. Gas clouds are drawn into these regions and compressed, and in those denser places, new stars can form. Young stars, especially the brightest and bluest ones, light up the arms. Clouds of glowing gas add to the brightness. Dust lanes trace darker ribbons along the curves, so the arms become both structure and scenery, both motion and light. It is also gentle to remember that the Milky Way's spiral form is something we infer. Because we live inside the disk, we cannot easily photograph our galaxy the way we photograph others. Instead, astronomers map it using many kinds of observations. They look at the distribution of gas, especially hydrogen, which can be traced through radio waves. They look at the positions of star-forming regions. They study the motions of stars and gas. They combine these clues into a picture of a spiral galaxy with multiple arms and branching features. It is not a single perfect drawing, but a careful, evolving understanding refined over time. And still, even without a perfect picture, we can sense the spiral nature of our home. The Milky Way's band across the sky thickens and brightens toward the center. Dark rifts appear, where dust blocks starlight. Star clouds gather in certain regions. With the right instruments, the galaxy's structure becomes clearer, and with the right imagination, it can become a soothing mental landscape, a wide rotating place where you can let your thoughts drift without pressure. As you rest, you might imagine the sun traveling on its long orbit, not in a straight line, but in a gentle curve around the center. In the span of your lifetime, the sun moves only a small fraction of that enormous circle. The stars that share our neighborhood move too, each on its own path. Over very long times, the relative positions of stars change. Constellations slowly reshape, and the sky becomes subtly different. But these changes are so slow that the night sky feels stable from one generation to the next, a steady canopy that invites calm. This steadiness is part of why the idea of a galactic year can be restful. It places your day inside a much larger continuity. The galaxy has turned for billions of years. It will continue to turn. And for tonight, while you lie still, you are part of that motion without needing to participate. Your body can rest. Your mind can loosen. The Milky Way does not hurry, and you do not need to hurry either. In the next part of our journey, we will begin to drift more closely into the spiral arms themselves, not as fixed painted stripes, but as flowing currents of stars and gas. We will imagine how they form, how they persist, and how they guide the gentle distribution of light across the disk. For now, you can let the galactic year remain as a quiet metronome in the background, a slow, dependable beat that helps everything feel a little more spacious. If your breathing is steady, you can notice it for a moment, then let it fade from attention. If your shoulders have softened, you can allow them to sink a little further. The galaxy continues its long orbit, and you can simply float along with it, in thought, carried by a rhythm that is older than mountains and calmer than any clock. Tonight, as we drift a little farther into our spiral home, we can let the Milky Way's turning become not only a clock, but also a kind of motion. You can almost feel like a slow current in a very wide sea. The galactic year gives us the scale of the journey, but the spiral arms give us the texture, the flowing patterns that make the galaxy feel alive and gently organized. And the most calming way to picture the arms is not as rigid lines, but as drifting shapes that guide where light gathers, where gas lingers, and where new stars quietly begin. When people first imagine spiral arms, they often picture them as long strands of stars that move together like the bristles of a rotating brush. But a spiral arm is not a single fixed object, and it is not made of the same stars forever. It is closer to a pattern that persists, while the contents slowly change. You can think of it like a slow traffic wave on a highway. The wave shape can remain in place while individual cars enter and leave it, each following its own path. In the Milky Way, stars orbit the center, and gas clouds orbit too. The spiral arms are regions where material tends to be a little more concentrated, and that concentration can help trigger star formation, which then makes the arms appear brighter. It can be soothing to imagine that the arms are not fences but lanes. They are not walls but gentle streams. A star does not need to belong to a spiral arm in the way a leaf belongs to a branch. Instead, stars and clouds drift through the arm region over time, spending some part of their orbit inside the denser pattern, and then moving onward. The arm is a place where the galaxy's flow gathers itself for a while, like water forming a slow whirl in a river bend. This is one reason spiral arms can look so dramatic in photographs of other galaxies. In the arms, gas clouds compress. When gas compresses, it can cool and clump, and within those clumps, new stars can form. Many of the brightest stars live fast, luminous lives, shining strongly and not lasting for very long on cosmic timescales. Because they do not travel far before they fade, they tend to mark the regions where they were born, so the arms can glow with young starlight, while older stars are spread more evenly throughout the disk, quietly orbiting in the background. Even if you do not hold on to the details, the feeling is gentle. The arms are places of softness and change. They are where the galaxy breathes in gas and breathes out light, where clouds gather and then slowly disperse, where star formation comes and goes like a slow tide. In the Milky Way, we can look towards certain directions in the sky and see more of this activity. Bright nebulae and clusters, hints that our view is passing through a spiral arm region where clouds and young stars are more common. Because we are inside the Milky Way, we see the arms from within, and that makes them feel less like a pinwheel and more like a layered landscape. When you look up on a clear, dark night, the Milky Way can show bright clumps and dark gaps. Some of the darkness is not empty space. It is dust-fine grains mixed with gas-blocking starlight and creating long, shadowy lanes. Dust is part of the spiral arm story too. It is made from the enriched material of older stars, spread into space by gentle winds and explosive endings, then gathered into clouds again. In that sense, dust is both memory and seed, both what remains and what will become. If you imagine drifting above the galaxy, you might picture the arms as curved bands that wrap around the center. But even that picture is an idealization. In real galaxies, arms can branch, split, fade, and reconnect. They can be more like braided streams than perfect spirals. Some galaxies have two prominent arms. Others have multiple arms. The Milky Way is understood to have several major arms and additional features, and astronomers refine the map as new observations arrive. For your resting mind, it is enough to imagine that our galaxy has curved currents, and that our solar system rides within this rotating disk, sometimes nearer to a denser lane, sometimes in a quieter stretch between. There is also a gentle idea in the science of spiral structure that many astronomers describe in terms of waves. In this view, spiral arms can be related to large-scale patterns in the disk, where gravity and rotation create regions of slightly higher density. The pattern can move through the disk in its own way, while stars and gas move through it like swimmers passing through a slow-moving swell. When gas enters a denser region, it can compress, and that compression can encourage the formation of new stars. Then, as the gas continues, it leaves the arm region behind, and the brightest newborn stars illuminate the path for a while. This wave-like picture fits nicely with the tone of tonight. It allows you to imagine spiral arms as something gentle and musical, a pattern that repeats not sharply, but softly. It also helps explain why spiral arms can persist over long times. Even though the stars in them are always changing, the pattern remains, while the contents flow through. As you rest, you might picture the Milky Way disk as a wide, slow-moving sheet of starlight with faint ripples and brighter currents. Some parts of the disk contain more gas, and those parts can be more active, forming stars glowing faintly in certain wavelengths. Other parts are quieter, filled mostly with older stars that shine steadily and drift on, keeping the galaxy luminous but calm. The arms, in this sense, are not a sign of chaos. They are a sign of organization, a calm structure arising from motion itself. And motion is the key. The Milky Way turns, and because it turns, patterns appear. The arms are a way the galaxy arranges its material, the way a rotating system can create curves and lanes. Gravity holds everything together, while rotation spreads the disk outward and keeps it from collapsing all at once. The balance between these forces creates a stable place where patterns can form and persist, and where the galaxy can continue its slow evolution. If your mind wants a simple image, you can imagine spiral arms like long drifting cloud bands similar to gentle weather patterns on a planet, but vastly larger. They are not storms with harsh edges. They are slow atmospheric rivers of star-forming material. In one part of the arm, a cloud may collapse into a cluster of stars. In another part, older clusters drift away and spread out. The arm remains as a general lane, not because the same objects stay there forever, but because the galaxy's dynamics keep encouraging that lane to exist. It is also calming to remember that the spiral arms are not only places of creation, but also places of passage. Over very long times, the Sun and the solar system may move relative to these patterns, crossing through arm regions and then out again. Such crossings are not sudden events. They unfold over spans that make them feel like slow seasons of the galaxy. If you imagine a galactic year, then crossing an arm might be like passing through a slightly brighter chapter of that year, a region where the night sky might contain more clusters and nebulae, more of the raw material of stars. For tonight, you do not need to follow that path. You can simply float in the idea of the arms as flowing currents, gentle lanes in a rotating disk. The Milky Way is not a static picture. It is a slow-moving story, and the spiral arms are some of its most graceful sentences written in gas and starlight. In the next part, we will continue drifting with these spiral currents and begin to connect them to a deeper, quieter structure, the unseen mass that shapes the galaxy's motion and helps hold its patterns in place. But for now, you can rest with the image of the arms as flow, a soft, swirling architecture that guides where the galaxy shines most brightly. If your breathing feels smooth, you can let it remain smooth. If your thoughts feel wide and slow, you can let them widen a little more. The spiral arms curve around the galaxy like gentle streams, and you are simply listening from within, letting the Milky Way turn overhead in the calmest way it knows. A little farther into this gentle journey, the spiral arms can begin to feel less like something we are trying to describe and more like something we are quietly traveling through, as if the Milky Way is a wide ocean and the arms are slow, moving currents, curving and returning, guiding where the brightest foam of young starlight gathers. When you picture them this way, there is no need for sharp lines. There is only motion, and the soft patterns motion can make when it has all the time in the world. In a spiral galaxy, the disk is full of stars, and it is also full of gas and dust, thin enough to be nearly invisible in ordinary daylight imagination, but real enough to shape the glow of the night sky. That gas does not simply sit still. It drifts along in orbit, responding to gravity pressure, magnetic fields, and the gentle push and pull of the surrounding environment. Over long times, it can gather into larger clouds. Within those clouds, smaller clumps can form. And inside the densest clumps, stars can be born, lighting up their neighborhoods for a while. This is part of what makes spiral arms so visible. They tend to be rich in gas and dust, and they are often traced by the bright, short-lived stars that form there. These young stars can shine with a clear intensity, and they often appear in groups, clusters, associations, or in loose gatherings along the arm. Nearby, gas clouds can glow too, energized by starlight, creating nebulae that add to the sense that the arms are luminous lanes across the disk. But it is important and oddly comforting to remember that the arms are not like carved grooves in wood. They are more like the path of a slow river, visible from above, not because the river is a rigid shape, but because water tends to flow along certain channels. In the galaxy, the channels are set by gravity and rotation. The pattern can persist even as individual stars and clouds move through it. One helpful way to think about this is to imagine a calm crowd moving around a circular walkway. If everyone walks at their own pace, the crowd spreads out. But if there is a gentle narrowing in the path, at certain points people may bunch together briefly as they pass through, then spread out again afterward. The narrowing does not need to be a wall. It can be a soft influence enough to encourage a temporary gathering. In a similar way, spiral arms can be regions where the gravitational environment and the dynamics of the disk encourage material to become slightly denser. Gas enters, compresses, and then moves onward. Astronomers often describe spiral arms using the language of waves or patterns. The idea is not that the galaxy is made of water, but that large-scale patterns can behave like waves in a system with many moving parts. In this view, the spiral arm is a region of enhanced density that can travel through the disk as a pattern, while stars and gas pass through it. The pattern is like a slow-moving ripple. The material is like the water. The ripple remains recognizable, even though the water is different at every moment. When gas flows into one of these denser regions, it can respond in a special way. Gas is compressible. It can squeeze and pile up. As it compresses, it can cool, and cooled gas is more likely to clump. These clumps can become the seeds of star formation. So the spiral arm becomes a place where the disk's material is gently encouraged to transform, where diffuse gas becomes cloud and cloud becomes stars. Then, as the gas continues along its orbit, it leaves the arm region, and the brightest new stars continue shining for a while, marking where they were born. Over time, the arm can look like a trail of light, not because the same stars remain in the same lane forever, but because new stars keep appearing in that lane, like candles lit along a path. Older stars, which live longer and have had more time to drift, spread out more evenly across the disk. This is why spiral arms often appear sharper in blue light, where young hot stars dominate, and smoother in other kinds of light where older populations shine more gently. You do not need to keep that detail. You can simply hold the idea that the arms are places where new light tends to appear. In the Milky Way, our view of the spiral arms is complicated by our position inside the disk. We look through layers of stars, clouds, and dust. We see bright regions, and we see dark rifts where dust blocks the light. Those dark lanes can feel like quiet rivers of shadow cutting across the Milky Way's glow. In reality, they are often dense clouds of dust and gas, the same kind of material that under the right conditions can form new stars. Even the darkness is part of the story of creation. Dust is especially gentle to imagine because it is so small and so influential at the same time. Each grain may be tiny, but together dust can dim starlight and shape what we see. Dust also helps gas cool by radiating energy away. And dust carries elements made in stars like a quiet cargo. In that sense, the spiral arms are not only lanes of light, they are lanes of recycled material. Star birth and star death feed the disk. The disk organizes that material into patterns. The patterns encourage more star birth. It is a slow cycle, not a dramatic one, more like a long, steady breathing. If you imagine the Milky Way from far away, you might see the arms curling outward from the brighter central region. But the arms are not identical. Some are more prominent. Some may split or branch. Some fade and reappear. This is normal. Galaxies are not perfect diagrams. They are living gravitational systems. They are shaped by internal dynamics, by the distribution of gas, by the influence of the central region, and by interactions with smaller companions. The spiral pattern can be stable for long periods, but it can also change gradually, shifting like a slow weather pattern over deep time. It can also be soothing to remember that in the arms, the most dramatic events, like the birth of bright stars, are still part of a gentle overall process. Stars form slowly inside clouds that may take millions of years to collapse. The light of a new star spreads through the surrounding gas, shaping the cloud and sometimes triggering more star formation nearby, like a soft chain of lanterns igniting down a road. From our perspective, this can feel like a story of brilliance. From the galaxy's perspective, it is simply one more calm way that matter rearranges itself. Some of the most beautiful images of spiral arms in other galaxies show pinkish glowing regions where gas is lit by young stars and dark dust lanes tracing the curves. These images are striking, but for tonight you can let them become softer in your mind like watercolor. You can picture the arms as pale ribbons, not sharp, not urgent, just gently brighter than the surrounding disk curving around the center in a slow dance. You might also notice a quiet paradox in the idea of spiral arms. They look like solid structures, and yet they are not fixed. They look like roads, and yet the cars are always changing. That paradox can be comforting, because it suggests that stability does not require stillness. A pattern can be stable, while everything inside it moves. A rhythm can persist, while every note is new. This is true in music and in the Milky Way. As you rest, you can let the spiral arms be a metaphor for your own thoughts tonight. Thoughts can drift through your mind the way stars drift through an arm. The pattern of the mind can remain calm even if individual thoughts come and go. You do not need to hold on to any one idea. You can let them pass through, leaving behind only a gentle glow. In the next part, we will begin to connect this flowing spiral structure to something even quieter, something we cannot see directly, but that shapes how the galaxy turns. Because the Milky Way's graceful spiral and its steady rotation are guided not only by what shines, but also by what remains invisible. For now, you can simply rest in the image of the arms as currents, and feel the comfort of a galaxy that organizes itself softly, turning through deep time, one calm orbit at a time. For a moment, let the spiral arms remain in your mind as gentle lanes of motion, because they lead us naturally to another soft truth about the Milky Way. Our galaxy is not a perfectly flat record spinning on a turntable. It is flatter than it is tall, yes, but even a wide disk can have subtle folds, bends, and waves, especially at its outer edges, where the pull of gravity becomes more delicate and where the galaxy meets its larger environment. When you picture the Milky Way as a living system, it can be comforting to imagine that it has the kind of small imperfections that make something feel real and calm, like a sheet that is never perfectly smooth, even when it lies still. From our place inside the disk, it is easy to assume that the galaxy is a neat level plane. The band of the Milky Way stretches across the sky and feels like a steady line, but astronomers have learned that the disk is slightly warped. It bends upward in some regions and downward in others, like the edges of a wide fabric responding to a slow, unseen breeze. This warp is not dramatic. It is a quiet, gradual bending that becomes more noticeable, far from the center, where the galaxy's structure is thinner and where the influence of interactions can become more apparent. One way scientists study this is by mapping hydrogen gas. Hydrogen is abundant, and it can be traced using radio waves that travel through dust more easily than visible light. When researchers map the hydrogen across the Milky Way, they see that the gas layer does not form a perfectly flat plane. Instead, it appears to rise and dip, creating a gentle three-dimensional shape. Stars can also participate in this bending, but hydrogen is often one of the clearest traces because it fills large regions of the disk and responds to gravitational influences. Now let us rest in a signature image, one that stays soft and sleep-friendly while remaining close to the science. Imagine the Milky Way disk as a silk sheet laid out in the dark, wide enough to cover the sky. Near the center, the silk lies flatter, held more tightly by the deeper gravity there, but toward the edges, it begins to lift and fall in slow folds. Scientists map this warp by tracing hydrogen gas across the galaxy, using radio observations that can slip through dust like a quiet whisper. The evidence suggests a bending, not a sharp kink, more like a gentle wave traveling through cloth. We are still learning exactly why the warp exists, but it may be shaped by the galaxy's environment, by the way the Milky Way moves through surrounding space, and by the subtle tugs of nearby companions. In this image, the warp is not a flaw. It is a sign that the galaxy is alive, responding, settling, always in motion, even when that motion is slow enough to feel like rest. When you return from that image, you can notice how well it fits the idea of spiral arms as flowing currents. A warped disk does not erase the spiral pattern. It simply adds depth to it. The arms sweep around the galaxy, but they do so on a surface that is slightly rippled, like currents moving across an ocean that is not perfectly level. In the outer regions where the warp becomes more apparent, the spiral structure can become more diffuse as well, and the disk itself can feel more like a faint mist than a sharp boundary. It is also gentle to consider that a galaxy is not isolated. The Milky Way sits in a local neighborhood of space, with smaller galaxies nearby, and it moves through a larger halo of material. Over long times, gravitational interactions, even subtle ones, can influence the disk. A small companion passing by can tug on the outer gas. The distribution of mass around the galaxy can encourage a slight bend. Gas falling in from outside can arrive with a tilt and gently pull the disk out of perfect alignment. None of these need to be sudden or violent in the way your mind might imagine from dramatic stories. In reality, much of the galaxy's evolution is slow, gradual, and almost quiet, measured in millions of years, guided by gravity's steady hand. When you look up at the Milky Way, you do not see the warp with your eyes. You see the glow of stars and the darkness of dust lanes. But it can be calming to know that beneath what we see, the galaxy has a gentle three-dimensional shape. It is not a flat diagram. It is a structure with subtle contours, and those contours are part of the same story as the spiral arms, because both are expressions of the disk, responding to rotation gravity and its surroundings. Spiral arms themselves can also be thought of as patterns on this slightly bent surface. Gas flows into arm regions, compresses, forms stars, and then drifts onward. The arms remain visible because the process repeats. In some places, the arm may be traced by bright clusters. In other places, it may be traced by clouds that are still forming stars quietly behind curtains of dust. The Milky Way's appearance changes depending on how you look in visible light, in infrared, in radio, in the gentle glow of different kinds of matter. Each view is like a different kind of night vision, showing a different layer of the same calm system. And this returns us to the feeling of flow. The spiral arms are not only pathways of light, they are pathways of material. Gas moves, dust drifts, magnetic fields thread through the disk, gravity guides the whole. If you imagine the galaxy as a slow-breathing body, then the spiral arms are part of its circulation, and the warp is part of its posture, the way it gently settles under the influence of its environment. As your thoughts slow down, you might notice how restful it is to picture a galaxy as something that can bend softly without breaking something, that can hold patterns while still being flexible. A warp does not mean instability. It means responsiveness. It means the Milky Way is not a rigid machine. It is a dynamic, patient structure that has been shaped over billions of years and continues to adjust quietly without hurry. In the next part, we will begin to move from these visible patterns and subtle bends into an even quieter foundation, something we cannot see directly, but that helps explain how galaxies rotate the way they do. We will drift into the idea of dark matter not as something frightening or dramatic, but as an invisible scaffold, a calm structure that holds the galaxy's motion together. For now, you can rest with the image of the Milky Way, as silk gently folded with spiral currents sliding across it, all of it turning together through deep time, calm and steady. For a moment, let the spiral arms remain in your mind as gentle lanes of motion because they lead us naturally to another soft truth about the Milky Way. Our galaxy is not a perfectly flat record spinning on a turntable. It is flatter than it is tall, yes, but even a wide disk can have subtle folds, bends and waves, especially at its outer edges, where the pull of gravity becomes more delicate and where the galaxy meets its larger environment. When you picture the Milky Way as a living system, it can be comforting to imagine that it has the kind of small imperfections that make something feel real and calm, like a sheet that is never perfectly smooth, even when it lies still. From our place inside the disk, it is easy to assume that the galaxy is a neat level plane. The band of the Milky Way stretches across the sky and feels like a steady line, but astronomers have learned that the disk is slightly warped. It bends upward in some regions and downward in others, like the edges of a wide fabric responding to a slow, unseen breeze. This warp is not dramatic. It is a quiet, gradual bending that becomes more noticeable, far from the center where the galaxy's structure is thinner and where the influence of interactions can become more apparent. One way scientists study this is by mapping hydrogen gas. Hydrogen is abundant, and it can be traced using radio waves that travel through dust more easily than visible light. When researchers map the hydrogen across the Milky Way, they see that the gas layer does not form a perfectly flat plane. Instead, it appears to rise and dip, creating a gentle three-dimensional shape. Stars can also participate in this bending, but hydrogen is often one of the clearest tracers because it fills large regions of the disk and responds to gravitational influences. Now let us rest in a signature image, one that stays soft and sleep-friendly while remaining close to the science. Imagine the Milky Way disk as a silk sheet laid out in the dark, wide enough to cover the sky. Near the center, the silk lies flatter, held more tightly by the deeper gravity there, but toward the edges, it begins to lift and fall in slow folds. Scientists map this warp by tracing hydrogen gas across the galaxy, using radio observations that can slip through dust like a quiet whisper. The evidence suggests a bending, not a sharp kink, more like a gentle wave traveling through cloth. We are still learning exactly why the warp exists, but it may be shaped by the galaxy's environment, by the way the Milky Way moves through surrounding space, and by the subtle tugs of nearby companions. In this image, the warp is not a flaw. It is a sign that the galaxy is alive, responding, settling, always in motion, even when that motion is slow enough to feel like rest. When you return from that image, you can notice how well it fits the idea of spiral arms as flowing currents. A warped disk does not erase the spiral pattern. It simply adds depth to it. The arms sweep around the galaxy, but they do so on a surface that is slightly rippled, like currents moving across an ocean that is not perfectly level. In the outer regions where the warp becomes more apparent, the spiral structure can become more diffuse as well, and the disk itself can feel more like a faint mist than a sharp boundary. It is also gentle to consider that a galaxy is not isolated. The Milky Way sits in a local neighborhood of space, with smaller galaxies nearby, and it moves through a larger halo of material. Over long times, gravitational interactions, even subtle ones, can influence the disk. A small companion passing by can tug on the outer gas. The distribution of mass around the galaxy can encourage a slight bend. Gas falling in from outside can arrive with a tilt and gently pull the disk out of perfect alignment. None of these need to be sudden or violent in the way your mind might imagine from dramatic stories. In reality, much of the galaxy's evolution is slow, gradual, and almost quiet, measured in millions of years, guided by gravity's steady hand. When you look up at the Milky Way, you do not see the warp with your eyes. You see the glow of stars and the darkness of dust lanes. But it can be calming to know that beneath what we see, the galaxy has a gentle three-dimensional shape. It is not a flat diagram. It is a structure with subtle contours, and those contours are part of the same story as the spiral arms, because both are expressions of the disk responding to rotation gravity and its surroundings. Spiral arms themselves can also be thought of as patterns on this slightly bent surface. Gas flows into arm regions, compresses, forms stars, and then drifts onward. The arms remain visible because the process repeats. In some places, the arm may be traced by bright clusters. In other places, it may be traced by clouds that are still forming stars quietly behind curtains of dust. The Milky Way's appearance changes depending on how you look in visible light, in infrared, in radio, in the gentle glow of different kinds of matter. Each view is like a different kind of night vision, showing a different layer of the same calm system. And this returns us to the feeling of flow. The spiral arms are not only pathways of light, they are pathways of material. Gas moves, dust drifts, magnetic fields thread through the disk. Gravity guides the whole. If you imagine the galaxy as a slow-breathing body, then the spiral arms are part of its circulation, and the warp is part of its posture, the way it gently settles under the influence of its environment. As your thoughts slow down, you might notice how restful it is to picture a galaxy as something that can bend softly without breaking, something that can hold patterns while still being flexible. A warp does not mean instability. It means responsiveness. It means the Milky Way is not a rigid machine. It is a dynamic, patient structure that has been shaped over billions of years and continues to adjust quietly without hurry. In the next part, we will begin to move from these visible patterns and subtle bends into an even quieter foundation, something we cannot see directly, but that helps explain how galaxies rotate the way they do. We will drift into the idea of dark matter, not as something frightening or dramatic, but as an invisible scaffold, a calm structure that holds the galaxy's motion together. For now, you can rest with the image of the Milky Way as silk gently folded, with spiral currents sliding across it, all of it turning together through deep time, calm and steady. Continue. A little farther on, as we drift from the visible glow of spiral arms and the gentle bend of the disk, we arrive at a quieter question, one that astronomers have been holding for many decades. When we watch the Milky Way turn, what exactly is doing the holding? The starlight shows us where many stars are, and the gas shows us where clouds drift and gather. but the way the galaxy moves suggests there is more mass than what we can easily see. This is not a dramatic revelation. It is more like noticing that a calm song has a deeper bass note underneath it, a steady support that you feel rather than hear. To understand why this question arose, you can imagine how scientists learn about a galaxy's structure. They watch motion. They measure how fast stars and gas orbit at different distances from the center. In a simple picture, if most of the mass were concentrated toward the center, then material farther out might move more slowly, the way distant planets in our solar system travel more gently in their orbits. The farther you go from the main concentration of mass, the weaker the pull, and the slower the orbit might become. That is the kind of behavior many people expect when they first think about gravity. But when astronomers study galaxies, including our own, they find that the rotation does not always slow down as much as the visible matter alone would suggest. The outer regions can orbit faster than expected, as if there is additional mass spread out beyond the bright disk. This is one of the clues that led to the idea of dark matter. It is not called dark because it is dangerous or ominous. It is called dark because it does not emit light the way stars do, and it does not shine in the same way gas clouds can glow. It is invisible to our eyes, and mostly invisible to our instruments that measure light. But it seems to reveal itself through gravity, through its quiet influence on motion. For tonight, you can hold dark matter as a gentle concept, an invisible presence that helps shape the galaxy without drawing attention to itself. If the Milky Way were a stage, stars would be the performers under the lights, and dark matter would be the structure behind the curtain, the beams and supports that keep the stage stable. The audience does not see those supports, but the performance relies on them. Astronomers infer this invisible mass using a few different lines of evidence, and the simplest to imagine is the rotation of galaxies. When we map how fast the Milky Way rotates at different distances, the motion suggests a gravitational field that is stronger than the visible stars and gas alone can account for. The conclusion is not that we have made a mistake about gravity, but that there is likely additional matter present, arranged in a more extended form. This additional matter is often described as a halo that surrounds the galaxy, extending far beyond the bright disk. It is not a solid shell. It is a diffuse distribution, like a wide invisible mist of mass that wraps around the Milky Way and helps guide its turning. If you let your mind rest with an image, you might picture the Milky Way disk as a bright spinning leaf, and around it an unseen shape, larger and softer, holding the leaf in its gentle field. The spiral arms sweep around within the disk, while the dark matter halo provides a broader gravitational setting. The arms do not directly depend on dark matter, in the way a building depends on a single pillar, but the overall stability and rotation of the galaxy are influenced by the total mass, both seen and unseen. This unseen scaffold can also help your mind feel calm about scale. The stars we see, even in great numbers, are only part of what makes a galaxy behave the way it does. There is something quiet and persistent in the idea that much of the universe may be structured by things that do not announce themselves with light. Not because the universe is hiding from us, but because nature does not require everything to glow. Some things simply pull, hold, and guide. You can also think of dark matter as part of why spiral arms can remain as long-lived patterns. The disk rotates within a gravitational environment, shaped by all its mass. The unseen mass contributes to the overall gravitational potential, which influences how stars and gas move. The details of spiral structure involve many factors, including how the disk responds to gravity and rotation, how gas behaves, and how patterns can form and persist. Dark matter is not the whole story of spiral arms, but it is part of the background that helps set the conditions in which a rotating disk can remain stable over long times, long enough for arms to appear as graceful lanes of flow. Another gentle clue astronomers use comes from the way gravity bends light from distant objects, an effect known as gravitational lensing. You do not need to picture this as a sharp distortion. It can be imagined as a subtle curving of a path, the way light might slightly shift as it passes through a region of mass. In some cases, observations suggest more mass than what is visible, again pointing to an unseen component. But tonight, it is enough to hold the quiet conclusion that the universe appears to contain more gravitational substance than what shines. It is also important to keep a soft uncertainty in the way we talk about dark matter, because while the evidence for extra mass through gravity is strong, the exact nature of dark matter remains something scientists continue to explore. Researchers have ideas, tests, and constraints, and many observations fit well with the dark matter picture, but the details of what it is made of are still being refined. For a sleep-friendly story, you can let this uncertainty be soothing rather than frustrating. It means the universe still has quiet mysteries, and they are being approached patiently with careful measurements, not with urgency. As you rest, you might notice how this idea shifts the feeling of the galaxy. The Milky Way is not only a luminous disk with spiral arms and a gentle warp. It is also embedded in a much larger envelope of mass, a wide halo that extends far beyond the stars we can see. That halo is part of what keeps the galaxy's outer regions moving, as they do part of what shapes the slow orbit of our Sun around the center, and part of what helps the Milky Way remain a coherent structure over billions of years. If the galaxy had a heartbeat, perhaps the visible part would be the soft shimmer of its arms, and the unseen part would be the steady pressure underneath the supportive rhythm that does not make a sound. Dark matter, in this sense, is like the quiet foundation of a house at night. You do not notice it. You do not need to. But it is there, holding everything gently in place. In the next part, we will settle into a longer signature reflection on this invisible scaffold, staying calm and fact-safe, and letting the concept feel like a gentle support rather than a complicated puzzle. After that, we will drift into the Milky Way's memory of encounters, the way small galaxies have merged and left streams of stars behind, and how the future meeting with Andromeda sits far ahead, like a distant, slow tide. For now, you can simply rest with the idea that the Milky Way turns within an unseen embrace, a wide halo that guides its motion quiet and patient, one calm orbit at a time. For a while, let us stay with the quiet idea of dark matter, because it fits the tone of this night so well. It is one of those concepts that can sound complicated when presented in sharp, technical language, but when you approach it gently, it becomes something simple and calming. It is the thought that gravity may be telling us a story that light alone cannot fully reveal, and that much of the structure of a galaxy may rest on an invisible support. In everyday life, we are used to learning about things by seeing them. Light reflects from surfaces and enters our eyes. A lamp reveals a room. A sunrise reveals a landscape. In astronomy, light is also a primary messenger. It tells us where stars are. It tells us about the gas between them. It can even tell us something about temperature, composition, and motion. But the universe is not required to show us everything through light. Some things may not glow, and yet still be present, still be important, still shape the motion of everything else. Dark matter is the name we give to this unseen influence, not because it is a shadowy presence in a story, but because it does not emit or reflect light in the usual ways. Scientists infer it because galaxies rotate in a way that suggests more mass than what we see in stars and gas. If the Milky Way were made only of what shines, then the outer regions might orbit more slowly than they do. Instead, the evidence suggests that the galaxy is embedded in a larger distribution of mass, a halo that extends well beyond the bright disk. Now let us move into a signature segment, letting the imagery remain calm and the facts remain safe, and allowing any numbers to stay soft and sparing. Imagine a quiet scaffold around the Milky Way, not built of metal or wood, but of gravity itself, an invisible frame that holds the galaxy's turning shape. We do not see this scaffold the way we see spiral arms or glowing clouds, but we sense it in motion, the way stars and gas keep orbiting with a steadiness that seems to ask for extra mass beyond what shines. Scientists call this hidden support dark matter, and the evidence suggests it forms a broad halo around the galaxy, larger than the luminous disk, reaching far into the quiet beyond the stars we can name. In this picture, dark matter is not a wall or a shell. It is more like a wide, gentle presence, a mist of mass that does not sparkle but that still has weight. We are still learning what it is made of, but its gravity appears to help keep galaxies like the Milky Way coherent over long stretches of time. It is the calm architecture behind the visible night sky, the part of the story that holds the shape steady even when it remains unseen. When you step back from that image, you can notice how restful it can be to think of the galaxy as having a quiet structure beneath its visible beauty. Spiral arms look like flowing patterns, and dark matter feels like the stage beneath the dance. It does not direct each individual star. Stars still follow their own orbits, and gas still responds to pressure and magnetic fields. But the overall gravitational field, created by all the mass, seen and unseen, shapes the environment in which the disk rotates. There is also a kind of humility in this idea. It suggests that our senses, even extended by powerful telescopes, may not capture everything. The universe can be full of things that are real and influential, without being obvious. And that can be soothing, because it means mystery is not a sign of danger or failure. It is simply part of the vastness. We learn by watching, measuring, and refining our understanding over time, like gradually recognizing a melody that was always there, beneath the louder instruments. Dark matter also connects to the larger story of galaxies interacting. When a small galaxy drifts close to the Milky Way, it does not interact only with the visible disk. It also moves through the Milky Way's dark matter halo. That halo contributes to the gravitational environment that guides orbits and can influence how companions are captured, stretched, and absorbed. In that sense, dark matter is part of the Milky Way's extended presence in space, part of the way it reaches out beyond its bright band. It is helpful to remember that even though dark matter is invisible, it is not an empty label. It is grounded in observation. When astronomers map the rotation of galaxies, when they study how clusters of galaxies move, and when they observe how mass can bend the paths of light from distant objects, they find patterns that point again and again toward an unseen mass component. Different observations taken together tell a consistent story that the universe contains more mass than what we can see as stars and glowing gas. The details are still being explored, but the broad picture has been steady for a long time. For a sleepy mind, you can hold this as a gentle truth. The Milky Way is not only what you see in the sky, it is also what you do not see, the gravitational presence that extends far beyond the band of starlight. Our solar system orbits within the galaxy's larger gravitational field. The galaxy orbits within the larger structure of the universe. Everything is nested, held within layers of influence, like calm circles drawn within calm circles. If you want an even softer metaphor, you can imagine the Milky Way's visible disk as a lantern, and the dark matter halo as the quiet air around it, not glowing but surrounding and holding the lantern in its place. Or you can imagine a tree whose leaves are the stars, shimmering in the night, while the trunk and roots are unseen in the dark, still supporting the whole. In each metaphor, the unseen is not threatening, it is simply foundational. As we drift onward, we will begin to move into the Milky Way's memory of encounters, because galaxies are not isolated islands. They grow and change over time, often by interacting with smaller companions. These interactions can leave faint, beautiful traces across the sky, long streams of stars that arc like pale ribbons. Some of these streams come from a smaller galaxy that is still being gently absorbed by the Milky Way, a companion often called the Sagittarius Dwarf Galaxy. And far ahead in time, another large neighbor, Andromeda, will approach in a slow future meeting, not like a sudden crash, but like a gradual blending shaped by gravity over immense spans. For now, you can let dark matter remain as a calm support in the background, an invisible scaffold that helps the Milky Way keep its shape while it continues its long turning. If your eyelids feel heavier, you can allow them to be heavy. If your breathing has become slow, you can let it stay slow. The galaxy continues its orbit, guided by what shines and what does not, and you are simply resting inside that gentle architecture, one calm orbit at a time. As we drift onward, the Milky Way begins to feel not only like a rotating home, but also like a place with a long memory. The spiral arms are part of its present-day flow, and the dark matter halo is part of its quiet support. But the galaxy has also been shaped by encounters by smaller companions that came close, and by the gentle, persistent work of gravity over immense spans of time. In this part of our journey, we will treat collisions and mergers not as something to fear, but as a kind of history, a slow layering of experiences that left faint signatures across the sky. It can be tempting to picture a galactic collision as a sudden crash, like objects striking in a dramatic moment. But galaxies are mostly empty space. The distances between stars are enormous. So when two galaxies interact, the most important forces are gravitational. Their stars mostly pass by each other, with wide spacing, while the overall shapes and orbits change through the combined pull of their mass. Gas can behave differently because gas clouds can compress and interact, and that can lead to new star formation in some cases. But the overall process is still slow unfolding across long timescales. In the language of deep time, even a collision can be gentle. The Milky Way, like many large galaxies, has grown over billions of years. One of the ways it grows is by gathering smaller galaxies, companions that orbit nearby, drift inward, and gradually become part of the larger system. This is not an unusual story in astronomy. It is one of the quiet patterns of cosmic evolution. A large galaxy pulls on smaller ones. The smaller ones lose energy over time through gravitational interactions, and their stars become part of the larger halo or disk. Their gas may be added as well. Over time, the larger galaxy becomes richer, more massive, and more layered, carrying within it the remnants of earlier companions, like faint memories embedded in its structure. One of the most vivid examples of this kind of ongoing interaction in our own galaxy involves a smaller companion, often called the Sagittarius dwarf galaxy. It is a satellite of the Milky Way, and it has been orbiting and interacting with our galaxy for a long time. As it moves through the Milky Way's gravitational field, it experiences tidal forces. Tides are not only an ocean phenomenon. In gravity, tides are the difference in pull across an object. The side of the dwarf galaxy closer to the Milky Way feels a stronger pull than the far side. Over time, this stretching can draw stars away from the dwarf galaxy and spread them along its orbit. These stripped stars can form what astronomers call stellar streams, long, faint ribbons of stars that arc through the halo. Streams are especially calming to imagine. They are not sharp boundaries. They are soft traces like pale brushstrokes across a dark canvas. A stream marks where a smaller system was gently pulled apart, not in a single moment, but gradually as it continued to orbit. The stars that once moved together inside a small galaxy can become a long, thin band still following a similar path, still telling a story of where they came from. In the Milky Way, stellar streams are part of the evidence that our galaxy has been shaped by mergers and accretion. Some streams are associated with known companions. Others may be remnants of older events whose original galaxies are no longer distinct. Over the past decades, as surveys have mapped the positions and motions of many stars, astronomers have found more and more of these structures, and the Milky Way has begun to look less like a smooth, uniform halo and more like a layered archive full of subtle patterns. It is as if the galaxy carries faint handwriting across its outskirts, lines that become clearer when you know how to look. When you picture the Milky Way this way, the galaxy becomes a calm museum of motion. Each stream is a display not behind glass but stretched across space. Each stream is a reminder that galaxies are not born fully formed. They grow and evolve. They interact. They remember. And the memory can be gentle, written not in loud events but in faint stellar pathways that persist for a very long time. It is also soothing to connect this to the dark matter halo we discussed earlier. The halo is part of the gravitational environment through which these smaller galaxies orbit. A dwarf galaxy does not only feel the pull of the bright disk and the central bulge, it also moves through the extended gravitational field of the halo. That broader field helps guide its orbit and shapes how the tidal stripping unfolds. In this way, the unseen and the seen work together. The luminous galaxy is the part we notice, but the larger mass distribution provides the stage on which these long interactions play out. The Sagittarius dwarf interaction is not the only one. The Milky Way has other satellite galaxies and has likely absorbed others in the past. Each interaction can leave behind streams, shells, or other patterns. Some events may have contributed stars to the halo. Some may have influenced the disk, perhaps even nudging it, adding to warps and waves, or subtly affecting the distribution of gas. None of this needs to feel alarming. It is simply the natural behavior of a galaxy living in a neighborhood of other galaxies bound together by gravity. And this brings us to an even larger relationship, one that sits far beyond the scale of a single night, far beyond the scale of human history. The Milky Way has a nearby companion of similar size, the Andromeda Galaxy. In the sky, Andromeda appears as a faint smudge in the right conditions, a soft oval of light. It is a separate galaxy, vast in its own right, with its own spiral structure, its own history, its own halo. And it is moving relative to us, slowly, steadily, as galaxies do. Over very long times, the Milky Way and Andromeda are expected to have a close encounter and likely a merger as they move under their mutual gravitational attraction. The details of the future are always approached with careful modeling and some uncertainty, but the broad expectation is that these two large galaxies will interact and eventually combine into a single larger system. If you are imagining something sudden, you can let that image soften. A galactic merger is not a single crash. It is more like a long dance. The galaxies approach. They distort each other's shapes through gravity. They may pass through each other, then separate, then return, gradually losing orbital energy and settling into a merged structure over time. In that future, the night sky would change from the viewpoint of a planet like Earth, though by then Earth itself may be very different, and the Sun will also be changing on its own long timeline. But as a calming thought experiment, you can imagine the two galaxies as slow-moving clouds of stars drifting closer, their halos overlapping long before their bright disks do. You can imagine streams forming arcs of stars, stretching new patterns, appearing like long ribbons drawn across the sky. And then, eventually, a new galaxy, emerging from the blending, perhaps more like an elliptical shape, or a rounded system, with a different kind of calm glow. The important feeling for tonight is not the exact outcome. It is the idea that galaxies carry time in their shapes, and that their interactions are part of a quiet cosmic ecology. The Milky Way has grown by gathering smaller companions, leaving streams as memory. In the far future, it will likely gather again, this time with a partner closer to its own size, and the two will become something new. The universe does not hurry. Its largest changes still happen slowly, guided by gravity, unfolding across spans so long that they can feel like a lullaby of deep time. If you return your mind to the present, you can remember that we are here, inside the Milky Way, in a calm region of the disk, far from the crowded center, looking out at these stories through careful observation and gentle inference. The galaxy around us is not a static home. It is a living history. It has tides. It has streams. It has companions. It has a future. And all of this can be held in a restful way because the time scales are immense and the motion is smooth. In the next part, we will begin to drift inward toward the Milky Way's core, where the central bar and bulge shape the inner dynamics, and where Sagittarius A star sits as a quiet, massive presence. For now, you can let the idea of mergers and streams fade into the background like faint starlight and return to your breathing, slow and steady. The Milky Way continues turning, carrying its memories in delicate ribbons across its halo and carrying you too gently, one calm orbit at a time. Now we can begin to drift inward gently from the wide memory of the halo and its faint stellar streams toward the brighter, busier heart of the Milky Way. The outer galaxy can feel spacious and quiet, with long orbits and wide separations, but the inner regions are different. Closer to the center stars orbit more quickly. The density of stars increases. The gravitational field becomes deeper, and the overall shape of the Milky Way begins to show features that are not as obvious from our position in the disk. A central bulge and a bar-like structure that stretches across the inner galaxy, guiding motion in a calm but powerful way. It can be soothing to imagine the Milky Way as having layers like a piece of music, with different instruments entering at different moments. Out in the disk, the melody is slow and open. Spiral arms drift like flowing currents. In the halo, the notes are faint and stretched into long ribbons. But toward the center, the rhythm tightens. The tempo becomes faster, not in a stressful way, but in the natural way. Gravity organizes motion more strongly, where mass is concentrated. The inner galaxy is a place where orbits are shorter, where stars crowd closer together, and where the structures of bar and bulge give the Milky Way a kind of inner shape, a posture, a calm stance. The bulge is the central swelling of stars, a thicker region in the middle of the disk, bright and dense. From our view, much of it is hidden behind dust when we look in visible light, because between us and the center lies a lot of material that blocks starlight. But in infrared and other wavelengths, astronomers can peer through more of that dust and study the central region more clearly. They find that the Milky Way is not just a simple disk with arms. It is a barred, spiral galaxy, with a bar of stars extending across its center, connected to the bulge, and influencing how gas and stars move in the inner regions. A bar is a common feature in spiral galaxies. It is like an elongated concentration of stars through the center, not a solid rod, but a pattern in the distribution of stars that rotates as part of the galaxy. The bar can act as a guide for motion, shaping the paths of stars and helping funnel gas inward along certain lanes. In the language of tonight, you can imagine the bar as a gentle current inside the larger ocean, a deeper flow that draws material toward the center, slowly feeding the inner galaxy. Gas, in particular, responds to this structure. While stars mostly pass through each other with great distances between gas clouds can collide and compress. In barred galaxies, the bar can drive gas toward the inner regions, where it may form rings of star formation or add material to the central environment. This is part of how the center remains dynamic, not chaotic but active, like a steady hearth that is occasionally replenished with new fuel. And within this inner region sits something that often captures attention: the Milky Way's central black hole, known as Sagittarius A star. Tonight we will treat it not as a monster, but as a quiet anchor, a massive presence that is mostly calm. A black hole at the center of a galaxy can sound like a dramatic idea, but the truth is often gentle. Sagittarius A star is far away from us, and it is not constantly consuming the galaxy. Most of the time it is relatively quiet, with only small amounts of material falling in. Its influence is strongest close to the center, where stars move in fast orbits around it, and where the gravitational field is deepest. Astronomers have been able to study Sagittarius A star indirectly by watching stars near the center. These stars orbit an invisible point, moving quickly on tight paths, and their motions reveal the presence of a massive object. When you watch those orbits in your mind, it can be calming to think of them as a kind of cosmic dance, a set of silent loops around a hidden center. The stars trace the gravity defines the rhythm, and the black hole itself remains unseen, like a quiet space in the middle of a whirlpool. Even as we speak of the central black hole, it is helpful to keep the larger picture. The Milky Way's center is shaped not only by Sagittarius A star, but also by the bulge and bar, by the dense cluster of stars, by the gas and dust clouds, by the magnetic fields and energetic processes that occur in crowded environments. The black hole is a key presence, but the galaxy's heart is an ecosystem, a complex inner region with many moving parts. If you let your mind drift with the imagery, you can imagine the bulge as a warm glow, a thickening of starlight toward the center, like a soft lantern behind a curtain. The bar can be imagined as an elongated beam, not bright like a spotlight, but like a gentle corridor of stars, rotating slowly as part of the galaxy, guiding flows inward. And Sagittarius A star can be imagined as a quiet point at the center of it all, a place where gravity becomes strongest, but where stillness also lives, because a black hole does not shine on its own. It is defined by what it does not let escape. This inner region also connects back to the spiral arms and the larger disk. The arms can be traced back toward the inner galaxy, where they meet the bar and bulge in complex ways. Patterns in a galaxy are not separate chapters. They are connected. The bar can influence the shape of the inner arms. The distribution of mass in the bulge can affect the rotation curve. The dark matter halo provides the broader gravitational environment, and the memory of past mergers can have subtle effects on the disk and its warps and waves. The Milky Way is one coherent system, turning as a whole, with different structures contributing to its shape. It can be restful to pause and simply feel the scale. The center is far away, tens of thousands of light years from us, hidden behind dust in visible light, but present in the galaxy's gravitational story. The Sun orbits at a safer distance in the disk, in a region where the sky can be dark and open. The center remains a distant heart, and the galactic year we began with is a measure of the Sun's long orbit around that heart, a slow loop that repeats over and over in deep time. In the next part, we will settle into one more signature reflection, focusing on Sagittarius A star as a dim lamp in the center, and on the stars that orbit nearby, keeping the imagery calm and keeping the numbers gentle. After that, we will begin closing the arc of this journey, tying the galactic year, the spiral flow, the unseen scaffold, the memory of mergers, and the heartbeat of the center, into one soft, restful picture of our spiral home. For now, you can let your breathing be the simplest rhythm in your world, while the galaxy's deeper rhythms continue in the distance. The Milky Way turns, the bar rotates, the bulge glows behind dust. The central gravity holds the inner orbits in place, and you can rest safely in the outer disk, listening to the idea of a galactic heartbeat that is calm and steady, one calm orbit at a time. For a moment, let us stay close to the Milky Way's center, but in a way that feels soft and unhurried, as if we are simply listening from far away, with no need to strain. The galactic core can sound busy in the language of astronomy, because there are many stars there, and many motions layered on top of each other. Yet it can also be imagined as quiet, because distance turns even the most energetic regions into faint light, and because the deepest anchor at the center does not shine in the usual way. Tonight we can hold the galactic center as a kind of heartbeat, not loud, not dramatic, but steady, a rhythm of orbits and gravity. The Milky Way's central black hole, Sagittarius A star, sits in the direction of Sagittarius, hidden behind dust in visible light, but revealed through careful observation in other wavelengths and through the motions of nearby stars. The name can sound like a bright star, but it refers to a compact, massive object, a place where gravity is concentrated. Scientists estimate it has a mass of a few million suns, a number that is large and strange, yet still calm in its effect on us, because it is far away, and because its gravity dominates only the region close to the center. Our solar system is safely in the disk, orbiting at a comfortable distance, carried along with many other stars. Now let us move into a signature segment, keeping the imagery gentle and the facts safe, and letting the center feel like a dim lamp rather than a spotlight. Imagine the galactic center as a distant room at the heart of a vast house, and in that room there is a lamp that is mostly turned down, glowing faintly, not with visible light, but with gravity. Sagittarius A star is that lamp, a supermassive black hole that does not shine on its own, but that shapes the motion of nearby stars. Astronomers have watched stars close to the center, trace fast looping orbits, as if they are circling an invisible hearth. From those orbits, scientists infer a mass of a few million suns concentrated into a region smaller than our minds want to picture. Most of the time, Sagittarius A star is quiet, with only small amounts of gas and dust drifting inward, occasionally producing brief flickers in certain wavelengths like a dim pulse rather than a steady blaze. The calm truth is that the center can be active without being violent in our story. It is simply deep gravity holding a busy inner neighborhood in place, while the rest of the galaxy turns around it in long, patient arcs. When you return from that image, you can let it connect with the bar and bulge we mentioned earlier. The bulge is the thick central swelling of stars, and the bar is an elongated structure of stars, extending through the center, rotating as part of the galaxy. These structures shape how stars move in the inner regions, and how gas flows. In some galaxies, bars can help drive gas inward, feeding star formation in rings or central regions, and sometimes influencing the environment near the central black hole. In the Milky Way, the bar and bulge are part of the core's architecture, like the inner frame of a rotating building guiding motion, without making any sound. It is calming to remember that galaxies are not organized like solar systems. In a solar system, planets orbit a single star, and the structure is dominated by that star's gravity. In a galaxy, there is no single bright central star guiding everything. The gravity comes from the combined mass of many stars, gas clouds, and the unseen halo. Sagittarius A star is massive, but it is not responsible for the orbit of the Sun on its own. The Sun's motion around the Milky Way is shaped by the entire distribution of mass in the galaxy, including the disk, the bulge, and the extended halo. The center is important, but the galaxy is a collective. This collective nature is part of what makes the Milky Way feel like a home rather than a simple machine. The spiral arms flow because the disk rotates and organizes itself into patterns. The warp appears because the disk is responsive, bending gently at the edges. The dark matter halo acts as an invisible scaffold, shaping the overall gravitational environment. Collisions and mergers leave streams faint memory ribbons in the halo. And at the heart, the bulge and bar define the inner posture, while Sagittarius A star holds a deep central place, quiet and steady. If you imagine all of this at once, you might feel overwhelmed, but you do not need to. You can let it become a single soft picture. Picture the Milky Way as a wide turning spiral like a slow pinwheel of light. Around it, imagine a larger, unseen halo that supports the motion. Along the outer regions, imagine faint streams like delicate threads of starlight, reminders of companions that were gathered over time. Toward the center, imagine a thicker glow, the bulge, and through it a gentle bar like a rotating corridor. And in the middle, imagine a quiet point where gravity deepens, a dim lamp that shapes the inner orbits. This is the heartbeat of the galaxy, if we choose to call it that. Not a thump, not a rush, a heartbeat measured in orbits, in steady rotation, in the long looping paths of stars around the center. It is a rhythm that can make your own worries feel small, in the kindest way, not because they do not matter, but because the universe is wide enough to hold them without strain. And now, as we near the end of this night's journey arc, we can return to where we began the galactic year. The Sun's long orbit around the center is like a slow walk around a distant hearth. In one lifetime, we take only a few steps along that path. In many lifetimes, we take a few more. Over hundreds of millions of years, the circle completes. The galaxy does not hurry, and it does not pause. It simply turns steady and patient. In the next part, we will begin to close this journey in a calm way, weaving the pieces together, the slow clock of the galactic year, the flowing spiral arms, the invisible scaffold, the memory of mergers, and the heartbeat of the core, leaving you with a gentle sense of place. For now, you can allow your thoughts to soften again. If your mind has been traveling, you can let it return to your breathing. The Milky Way's center remains distant, quiet, and steady, and you remain here resting safe in the outer disk, one calm orbit at a time. Now we can let the Milky Way become whole again in your mind, not as separate topics, but as one calm, connected home. The journey order we followed tonight is like a gentle walk through a garden, moving from one path to another, yet always remaining inside the same peaceful space. We began with the galactic year, the slow clock of motion. We drifted into the spiral arms as flowing currents. We rested with dark matter as an invisible scaffold. We listened to the memory of collisions and mergers, the faint streams, the Sagittarius dwarf, and the distant future of Andromeda. And we arrived at the core with its bulge bar and the quiet presence of Sagittarius A star. Now we can weave these pieces together in a way that feels like settling into sleep. A galaxy is a system of relationships. Nothing stands alone. The galactic year is not only a number, it is a reminder that our solar system belongs to the Milky Way's larger turning. It is the rhythm that holds our local story inside a broader story. When you picture the sun moving along its long orbit, you can imagine it as a small light traveling on a wide track, not rushed, not pulled in sudden jerks, but guided smoothly by the combined gravity of the galaxy. The sun's path is part of a shared motion. Countless other stars follow their own paths too, some slightly faster, some slightly slower, each tracing an arc around the center. Together, they form a steady rotation, like a slow choir of movement. On that rotating stage, the spiral arms appear. They are not painted lines. They are patterns that arise from flow. Gas drifts through the disk. Density gathers in certain curved lanes. Clouds compress. Stars form. Young stars shine brightly for a while and mark the arms with light. Then those stars drift onward and fade into the broader population. The arms persist because the conditions that form them persist, and because the galaxy continues turning. In this way, the spiral arms are a kind of moving architecture, a soft design made from motion itself. You can remember the arms as currents, because that image keeps them calm. Currents carry. Currents gather and release. They do not need to be harsh. The Milky Way's arms guide, where star formation happens more readily, where the galaxy's glow becomes more textured, and those arms ride on a disk that is not perfectly flat. The disk can warp. The warp is a gentle bending at the edges, seen in maps of hydrogen gas, a subtle wave in the galaxy's wide sheet. It is one more reminder that the Milky Way is alive, responsive, and shaped by its environment. Beneath all of this lies the quiet support of dark matter. We do not see it directly, but the way the Milky Way rotates suggests that more mass is present than what shines. The invisible scaffold, the halo, extends far beyond the luminous disk. It helps shape the overall gravitational field in which the disk turns, and in which the sun follows its long orbit. For a sleepy mind, it can be comforting to think that much of the universe is held by things that do not draw attention to themselves. The unseen can still be steady. The invisible can still be supportive. Then there is the Milky Way's memory. Galaxies grow over time, often by gathering smaller companions. The Sagittarius dwarf galaxy is one example of an ongoing interaction, where tidal forces pull stars into long streams, faint ribbons across the halo. These streams are like handwriting in starlight, a record of where a smaller system was stretched and absorbed. And beyond the present, the Milky Way has a future relationship with Andromeda, a distant companion of similar size. Over immense spans, the two are expected to interact and likely merge. This does not need to feel frightening. A galactic merger is a slow dance, a gradual blending guided by gravity. It is change on a scale that is patient change, that unfolds over deep time. And at the center, the Milky Way has its heartbeat. The bulge thickens the inner glow. The bar stretches through the center and guides inner motion, and gas flows. Sagittarius. A star sits as a quiet anchor, a supermassive black hole with a mass of a few million suns, mostly calm, revealed through the fast orbits of nearby stars and occasional faint flickers. The center is not a roaring furnace in our story. It is a deep gravitational place, shaping the inner galaxy's rhythm. while the outer disk continues its long, unhurried orbit. If you gather all of this into one gentle picture, it becomes something like this. The Milky Way is a wide, softly warped disk. Spiral arms curl through it like slow currents. A larger, unseen halo surrounds it, supporting its motion. Faint stellar streams arc through the outskirts, memories of companions gathered over time. Toward the middle, the disk thickens into a bulge, and a bar rotates through the center. And at the heart is a quiet gravitational point, Sagittarius, a star mostly still holding the inner orbits in their fast looping dance. Around all of it, the galaxy turns, and within that turning, our solar system rides calmly along. You can let this picture become less like information and more like atmosphere. You do not have to remember each detail. You can let the feeling remain. A galaxy can be both structured and flowing. It can be both bright and unseen. It can carry memory and still feel calm. And it can have a heartbeat that is measured not in seconds, but in orbits that take longer than any human story. As you rest, you might return to the opening idea of the galactic year and let it be your last gentle thought. The sun is traveling around the Milky Way's center, and it has done so many times over the galaxy's long life. Tonight you are part of that motion, not as an effort, but as a background truth. Your body can be still while the universe moves. Your mind can become quiet while the galaxy turns. Nothing needs to be solved. Nothing needs to be rushed. If you are still awake, you can let your breathing slow again, as if you are matching the calm pace of deep time. If your eyelids are heavy, you can allow them to stay heavy. And if your thoughts are drifting, you can let them drift the way stars drift, through spiral arms passing through patterns without needing to cling. In the next and final part, we will close this journey, softly returning you to rest with a sense of gentle gratitude for the night sky, and leaving the Milky Way turning quietly in the background, one calm orbit at a time. As we come to the gentle end of this journey, you can let the Milky Way remain where it belongs, not as a problem to understand, but as a calm presence in the background of your night. It is there, whether you name its parts or not. It turns, whether you watch it or not. And it holds you not in the sense of holding you tightly, but in the sense that you live inside its wide, patient motion like a small boat resting on a slow sea. If you look up at the night sky from a quiet place, you might see only a few stars. Or you might see many. You might see the Milky Way itself, that pale river of light if the night is dark enough and the air is clear. But even when you cannot see it, it is still above you, around you, and in a way within you too, because every atom of your body was formed in a universe that has been cycling matter through stars for a very long time. That thought can feel tender rather than heavy. It means you belong to the same calm processes that shape galaxies. You are part of a story that is older than you, and also gentle enough to let you rest. Tonight, we followed the Milky Way's arc in a specific order, like walking a winding path that leads from the outer quiet into the inner glow. We began with the galactic year, the slow rhythm of the sun's orbit around the center, a clock that moves so slowly it feels like stillness. We drifted into the spiral arms, not as rigid lines, but as flowing currents, where gas gathers and young stars light the lanes for a while. We rested with the idea of dark matter, an invisible scaffold inferred from motion, a quiet support that helps explain the galaxy's steady turning. We listened to the memory of mergers, the Sagittarius dwarf, and its stellar streams, the faint ribbons that mark where gravity gently stretched a companion over time. We looked ahead to Andromeda, a distant neighbor, whose future encounter with the Milky Way will unfold like a slow dance across deep time. And we arrived at the core, with its bulge and bar, and the quiet gravitational lamp of Sagittarius A star. Now you can let all of those pieces soften and blend into one simple feeling. The Milky Way is a calm spiral home. It is not a still picture, but a slow turning system. It is not perfect and flat, but gently warped and responsive. It is not only what shines, but also what holds. It is not only present, but also memory, carrying traces of past companions across its halo. And it is not only wide, but also centered with a distant heart, where gravity deepens and the inner orbits move with a quicker rhythm. If a galaxy could breathe, perhaps its breath would not be a gust, Perhaps it would be the slow pulse of rotation, the steady movement of stars around the center, the gradual drift of gas through spiral lanes, the quiet gathering and release of material that becomes new light. And perhaps its heartbeat would not be loud either. Perhaps it would be the simple fact that the Milky Way continues to turn, and that this turning has lasted for billions of years, and that it will continue long after any single night has passed. You can let that steadiness be your comfort. A long day can make the mind feel crowded, and sleep can feel like something you have to chase. But tonight, you can let rest come to you instead. You have got nothing to do but rest. Your breath can be slow. Your shoulders can be soft. Your body can sink a little deeper into whatever supports you, a bed, a pillow, a chair, the quiet weight of the night. And if thoughts appear, you can let them pass as gently as starlight passing through a thin cloud. The Milky Way does not demand attention. It does not judge. It simply moves. And in that movement, there is room for you to be still. There is room for your mind to loosen. There is room for the day to fade. The universe can be vast without being harsh. It can be mysterious without being threatening. It can be full of unseen structure and long memory, and still feel like a calm place to exist for a little while. If you want one last image to carry with you into sleep, you can picture the galaxy as a slow wheel in the dark. The spiral arms are soft, curved currents. The disk is like silk, gently bent at the edges. The halo is an invisible warmth around it, holding its motion. Faint streams drift like pale ribbons, far out, barely there but real. And the center is a quiet hearth, a deep point of gravity where stars circle in a steady dance. Around that hearth, the sun follows its long orbit, and within the sun's orbit, Earth follows its smaller one. And within Earth's orbit, you breathe here now safe. You do not need to stay awake to keep the galaxy turning. It will turn without you. You can let your awareness fade and trust that the universe will still be there in the morning, calm and patient, waiting quietly for whenever you are ready to look again.